In this video, we are going to learn how to solve natural log equations by using its inverse with a base of e. The first thing we want to be able to do anytime we're using this is isolate our natural log function. So we need to get rid of this 4 by pushing it over to the other side of the equal sign. So I'm going to take that and subtract it off to the other side. So that goes away and leaves me with a natural log of 5x minus 3 is now equal to 11. At this point, we've got our natural logarithm by itself. We want to take this and turn it into an exponential. And the way we're going to do that is by taking the base of e, which is the implied base of the natural log, and pushing that base of e over to the other side. So in doing so, I get the new equation 5x minus 3 equals e raised to the 11th power. Now the nice thing about this is our x is no longer trapped inside of our natural logarithm. So at this point, we can go ahead and try to isolate x just by using our basic properties of algebra. So if we come up here, the first thing I'd want to move is our 3. So I'm going to add 3 to both sides. So I get 5x equals e raised to the 11th power plus 3. And then our final step to get x by itself, we would want to divide off the 5 from both sides. So that 5 is gone, and I get x equals the fraction of e raised to the 11th plus 3, all being divided by 5. And that would be our exact solution if that's what we wanted. Or we could go ahead and put this into a calculator to evaluate it. And when I put this into the calculator, I end up getting that x itself equals 11,975.43. Quite a large number, but when we raise something to the 11th power, it does get quite large. So the first thing we wanted to do when we were solving this was isolate the natural logarithm, and we accomplished that by subtracting out the 4. We then used the fact that the natural logarithm has a base of e to move that base over to the other side as an exponential base. Once we had done that, we could use our properties of algebra to subtract the 3, or add the 3, and divide off the 5 to isolate x. And ultimately, we got x to equal 11,975.43.